So today we're going to calculate the slope of a line from its equation. And we're going to do both forms of the equation. We're going to do standard form, which is ax plus by equals c. And we're going to do slope-intercept form, which is y equals mx plus b. There's a way to do this for both types of equation. So the one we're going to start with today is y equals mx plus b, slope-intercept form. In this form, the slope is m, and that means the coefficient of x, or the number in front of x, when you have an equation in the form y equals mx plus b. So if we look at example 6, it says find the slope of the line with the equation y equals 5x minus 3. This is as simple as this. Slope equals 5. Because 5 is the coefficient of x. This is a very easy way to find the slope of a line from its equation. So let's go down to example 7, and we have 4 equations where we're going to find slope. This first one, A, this is in perfect slope-intercept form. So our slope is what's in front of x, or the coefficient of x. So slope equals negative 1/3. Let's go down here to C. C is also in slope-intercept form. It's just that instead of having the x next to its coefficient, it's in the numerator with the 3 of the coefficient. It still works the same way. The coefficient of x is 3 over 2, so the slope is 3 over 2. All right, if we take a look at B, there's an issue with B. B is not in slope-intercept form, and the reason it's not is because the y term has a coefficient of 3. In slope-intercept form, the coefficient of y has to be positive 1. So we need to fix this and to make our equation in slope-intercept form in order to find the slope. So what we're going to do, divide all 3 parts of this equation by 3. And the equation in slope-intercept form is y equals 5/3 x minus 2. So now we can find our slope. It is the coefficient of x, and that equals 5/3. Now, example D, we can't get the slope yet. This is not in slope-intercept form. In order for this to be in slope-intercept form, we need to have y equals mx plus b. The x is on the wrong side, the y is on the wrong side. So we need to fix all that before we can find slope. One of the things I can do to get that to occur is, since x and y are both on the wrong side of the equation, I'm just going to flip the 2 sides of the equation. So I have 5y plus 1 equals x. And what that did for me was get the x on the right side and the y on the left side. But now I need the 1 on the other side, so subtract 1 on both sides. I have 5y equals x minus 1. And I still don't have this in perfect slope-intercept form because I have a 5 in front of my y. So I need to divide everything by 5. And I have y equals x over 5 minus 1/5. Now this is in slope-intercept form, so now I can find my slope. And my slope in this particular case is the coefficient of x, and that slope is 1/5. It's very easy to find the slope in slope-intercept form. But we also have a way to do this when we're in standard form. So let's go backwards to page 11 of our notes. There's a formula to find slope when you have an equation in standard form. And here's that formula. If you have an equation in standard form, ax plus by equals c, then the slope is negative a over b. And I'd like to show you where that comes from, because it doesn't come from nowhere. What I'm going to do is let's take the equation ax plus by equals c, and let's do this. Let's write this in slope-intercept form. So we need to move our x's to the other side. So subtract ax on both sides. And I have by equals negative ax plus c. Now, in order to have this in slope-intercept form, I can't have a number in front of y, so I'm going to divide by that number in all three parts. And so now these b's cancel, and I have y equals negative a over b times x plus c over b. And so what we can see, we now have this in slope-intercept form. We know that whatever is in front of x is our slope, and that is negative a over b. And that's why we can use the formula negative a over b. So let's go ahead and do that in example 4. In example 4, we have 2x minus 5y equals 9. The coefficient of x is our a. The coefficient of y is our b. So I'm labeling those. My slope equals negative a over b, so I'm going to put a negative out front. My a is 2. My b is negative 5. My two negatives cancel to become a positive, and so my slope is 2 over 5. Now, if I take this equation in standard form and I rewrite it in slope-intercept form, I will also find that my slope is 2 over 5. So when you have an equation in standard form, you now have two options. You can either use this formula, slope equals negative a over b, or you can rewrite the equation in slope-intercept form and use the coefficient of x as your slope. On this page, what I'd like us to do is practice using this formula. So let's go down to example 5, and I have 4 equations where we're going to do this. So first of all, I do have an equation here in standard form, so I'm going to write my formula. Slope equals negative a over b. So I'm going to put my negative out front. A, the coefficient of x, is 1. B, the coefficient of y, is negative 3. The two negatives are going to cancel, and my slope is 1/3. Let's go to equation B. Again, I've got an equation in standard form, so I'm going to use my formula, slope equals negative a over b. So I'm going to put a negative out front. My a is 4, so that goes in my numerator. My b, the coefficient of y, is negative 1. That goes in my denominator. The two negatives in this case cancel, and my slope is 4 over 1, which is just 4. If we go to C, again I have an equation in slope-intercept form, so I'm going to write my formula. Slope equals negative a over b. So I'm going to put my negative out front. The coefficient of a, or of x, is 1, so that goes in the numerator. The coefficient of y is 1, that goes in the denominator. Negative 1 over 1 gives me a slope of just negative 1. My last example here. Again, I have an equation in standard form. I'm going to write my formula. Slope equals negative a over b. Put a negative out front. A is 3, so that goes in the numerator. B is 7, that goes in the denominator. And my slope is negative 3 over 7. Now, I also want to go back to horizontal and vertical lines. And that was page 13 of our notes. We talked about that yesterday. Here's what we have to remember. If we come across an equation that has y equals a number and it has no x's in it, neither of the two methods we just talked about is obviously going to work because we don't have something in standard form and we don't have something in slope-intercept form. What you have to remember is if you have no x's in your equation, it is an equation for a horizontal line. All horizontal lines have the slope of 0. So if you have an equation that's y equals a number and there are no x's, the slope is 0. It's just a fact you'll have to memorize. Similarly, for vertical lines, you're going to have an equation with an x, and it's not going to have any y's in the equation. So you can't use the method for standard form or for slope-intercept form. What you're going to have to do is recognize that with no y's in the equation, this is an equation for a vertical line. And the slope of all vertical lines is undefined. All right? So these are actually easier because you can just know the slope by looking at them. But you've got to remember which one is which and what is the slope of that particular type of line. Horizontal lines have 0 slope, and vertical lines have undefined slope. Now I want to touch on a phrase which I see students use and is used in the book, and I want to make sure we use it correctly. And that is the term no slope. No slope. What does no slope mean? Sometimes students use this to mean 0. It does not. If you use the terminology no slope, it means the slope does not exist and it equals undefined. So if you are going to use it, know this. I will take it to mean undefined, not slope of 0. 0 is a number. If a line has a slope of 0, you need to put 0 as the slope. If you use no slope, you mean undefined.